Unit 6, Lesson 7, Equivalent Expressions. This lesson will focus on simplifying expressions and writing equivalent expressions. The essential question for the lesson, how can properties help you write equivalent algebraic expressions, will be discussed during the lesson. In a previous lesson, we discussed the different parts of an expression. Each one of these that you see pictured here, this whole thing is an expression, and each different part is also an expression. One of the vocabulary words that we talked about was the word term, and you will notice from that lesson or recall that a term is separated by an addition or subtraction symbol. So if you're looking at this expression, you will count that there are 1, 2, 3, 4 different terms in this expression. You will recall from last week when we looked at the video, the Mad TV video, a way to make that order a lot simpler was to combine things that were the same. And we learned that we can combine like terms. So we were discussing terms. Each one of these expressions or different parts of this expression are a term, and we can combine like terms. Taking a look at letter A, the number 3 and the number 11 are constants in this expression, and they can be combined. So 3 plus 11 more is 14. And because x is a different type of term, we cannot combine it, but we can simplify this by writing 14x. In letter B, all of these are the same type of term, and so they can be combined, and there are 1, 2, 3 x's, and we write just that, 3 x's. In the next expression here, we can simplify by combining the x's. Here's an x term here, and here's one here. There are 7 x's here, and one more here, which makes 8 x's. And because the 8 is a constant, it's a different type of term and cannot be combined. So letter C simplifies to 8x plus 8. Our next expression here, we're looking at the different terms, and this term and this term are the same, are similar, and they can be combined. We have 3 m's here and 2 m's here, so we have 5 m's. This is a different type of term with a different variable pattern, so we can not combine it. We just keep it there. So this whole lesson is focusing on how can we simplify and create an equivalent expression by combining like terms. In this next example here, we have 2 x's here and 7 more here, which gives us 9 x's. And this is a different type of term, so it cannot be combined, so we keep that. In this next example here, we're looking and the s's are the same, so we can combine those two like terms. 6 plus 9 gives us 15 s's, and the 8 does not have anything else that can go with it, and because we don't know the variable, we cannot combine any further, so we have 8r plus 15s. Another way to simplify expressions, again, we want to combine those terms that are the same. And these are very similar to the ones that we just looked at, but here's a different one here. We have 14y's, an x, and we have 22 more y's here. And the y's are different, so we can combine them, and we end up with 36y plus that x that we cannot combine. And I do apologize, I just realized these are exactly the same as from the previous page, so we are not going to do those. We are going to look at the next way that we can simplify expressions, and it is through the distributive property. In a previous lesson, we talked about how to use the distributive property to simplify and create an equivalent expression. Just remember that that 4 outside of the parentheses means we're going to multiply it, and we need to multiply it by everything in the parentheses that distributes that 4. So we'll have 4 times 2x, which gives us 8x, and 4 times y, which gives us plus 4y. In this next example, we're going to do the exact same thing. Distribute the 7. 7 times 3 is 21 x's, and 7 times y gives us 7y. 4 times 2 gives us 8 x's, and 4 times 5y gives us 20y. Now remember, this is simplifying this expression, but also creating an equivalent expression. 7 times 3x plus y is the same as 21x plus 7y. This last example here, 6 times 4m gives us 24m. And 6 times 2n gives us 12n. Another way that we can simplify expressions or create, again, an equivalent expression is to factor. And factoring, we should remember that it requires us to find the greatest common factor that these two expressions have in common, or two parts of this expression. We learned last week that we can use the ladder method to do this. And the ladder method has us looking at those prime numbers. 2, 3, 5, 7 are usually our basic ones, and usually if we use those, we will simplify it into its smallest prime units. These two are not both divisible by 2, so we'll move on to 3. They are both divisible by 3. 27 divided by 3 gives us 9x. And 18 divided by 3 gives us 6y. 9 and 6 are also divisible by 3, so I'm going to divide by 3 again. 9 divided by 3x gives us 3x, and 6y divided by 3 gives us 2y. And these are in their smallest prime components, cannot be simplified anymore. So we find our greatest common factor, which is found by multiplying the numbers that we end up with on the side, and it is 9. And then we're left with these units, or different parts of the expression, inside of the parentheses, because they cannot be factored any further. Moving on, we can do the same thing here. We're just continuing to practice what we learned in class. And I'm just going to use this here. These are both divisible by 2. 12 divided by 2 is 6. 8 divided by 2 is 4. Make sure I keep my variables. I cannot lose those. These are both also divisible by 2. So 6 divided by 2 gives me 3x. And 4y divided by 2 gives me 2y. The GCF is found by multiplying the numbers on the side there. So we have 4 and 3x plus 2y are left in the parentheses. These two here. If I try to divide by 2, I can divide this by 2, but not the 35. I can't divide them either by 3 This is divisible by 5, but this one is not. So I move on to that last number, which is 7. And 35 divided by 7 gives me 5r. And 28 divided by 7 leaves me with 4s. These cannot be simplified any further, so my expression is 7 times 5r plus 4s. Now, most of you would probably want to jump right to dividing by 10, but we're using our prime numbers. That's how we get that prime component. 30m divided by 5 gives us 6m. 10 divided by 5 gives us 2n. And these again are divisible by 2. 6 divided by 2 gives me 3m. And 2 divided by 2 leaves me with n. 1n, but we do not need to put the 1. Our greatest common factor are these two numbers multiplied together, so it's 10. And then we have 3m plus n left in the parentheses. Okay, so now I want you all to pause the video for a moment and try these problems on your own, and then you can restart and see how you did. This first example here, we can combine the y values. So we're going to be left with 6 plus 4y. This letter n is requiring us to use the distributive property the way it's set up. So we're going to do 5 times 2y, which gives us 10y. And 5 times x gives us 5x. In this example here, we have f's here and we have f's here. And we have to pay attention to the symbol here in front because it says 7f's here minus 3f's. So we actually only have 4f's left. And then we have 2g. In this next example, remember, parentheses means we are going to multiply, so we have 4 times 5z, which gives us 20z. In this next example, we have k here, and k here. So we have 3 k's plus 1 more gives us 4, and 2 more gives us 6 k's. And in this last example, we are looking to factor. So I'm going to divide by 2. 48 divided by 2 gives me 24. I'm going to divide by 2 again. Make sure I keep that variable. And it looks like I can divide by 2 again. And now I'm ready to write my expression. My GCF that I factored out is 2 times 2 times 2, which gives me 8. I'm left with B minus 6C in parentheses. How did you do? I hope you all did very well with that. This last set of questions are for you to practice for tomorrow's class.